Okay, for this one, we've given velocity in terms of time. So we know if we differentiate, because d to t is acceleration, so if I differentiate, I'm going to get acceleration. So that was a double dot. That didn't work, so why don't I go, there we go. So if I differentiate with respect to t, you can see the minus 2 will come down, so I'll get a minus 2 times minus 3, so I'll get 6 e to the minus 2t. So that's acceleration. Now, if you look at what we're trying to show that here, we've got v's and x's there, so I really want acceleration in terms of, not in terms of t. So I'll see if I can express it in terms of v. So if you think about it, actually, if I change this and make the 3e to the minus 2t the subject, you can see I have 8 minus v, just like that. So this looks really similar to that. You can see it's just 2 lots of 3e to the minus 2t's. So that is the same as 2 lots of 8 minus v. So now I've got acceleration in terms of v, and you can see what we're trying to show that up here. So I can use v to v dx, because acceleration is in terms of v. I can use v to v dx equaling to 8 minus v, and I can put everything upside down. So we get that, and then we can, oh, is that what we had to show? Oh yeah, and then I can put, yes, so I don't need to show too much, do I? So remember, I'm show that, I don't need to actually figure it out. So I'm going to multiply this 2 up to the other side, so it becomes 2 dx with an integral, and I'm going to multiply the v to v up on the other side, so I get v on 8 minus v to v on the other side. So I've just turned it around, but we've got to show that. All right, so you can use the v and put it back into the acceleration if you've got v to v dx. Just remember that. All right, so part B, we want distance travelled. So we're looking at x's when the speed increases from 0 to 7, as its speed increases from 0 to 7. So we're going to use that, what we're given right there. So let me just make a bit of room here. So let's go back to the show that. We've got v on 8 minus v to v. And we're going between 0 and 7. And we know that this, so we want the distance that's travelled in this time. So we're going from 0 to some distance, let's say d, of 2 dx. All right, so if I change colour and put a minus there and a minus here, and also put an 8 in there, so I'm going to then minus an 8 here. All right, so what does that give us? So we actually get a minus integral of 1, 8 minus v on 8 minus v is 1, and then we're going to have a minus 8 on 8 minus v to v. Here, let's just integrate. So 2 becomes 2x, so 2x between 0 and d, so we know we're going to get 2d minus 0, so 2d's. Here, if we go back to the left-hand side, when we integrate here, we're going to get a v, and we've got that minus 8 over 8 minus v, so that's a positive 8 log 8 minus v between 0 and 7. Sorry, that didn't line up very well. So let's sub the 7 in, so we get a log 1, which is just 0, and then sub the 0 in, so we get minus 0 minus 8 log 8 there, equaling 2d. All right, so what have we got here? Actually, a minus 7, the middle terms are 0, then we've got minus minus, so positive 8 log 8 equaling 2d. So what does our d equal? It equals half of that, so we get a 4 log 8 minus a 7 on 2 if we want the exact answer, or put that in the calculator. We get 4.82 meters approximately.